This is my predicted paper for the 16th of May 2024, the non-calculated paper this year, and it ultimately just looks at lots of the topics that have come up, lots on the non-calculated paper in previous years. I hope you enjoy it. Let me know in the comments what you think or if you've got any questions as you go. Question number 1, write 4/5 as a decimal. So to write a fraction as a decimal, it's going to be easier if it's out of 10 or out of 100. So I'm going to make this an equivalent fraction, but I'm going to make it out of 10 instead. Now the reason I've chosen to make it out of 10 is because the denominator is currently 5. So to make that out of 10, all we need to do is multiply by 2. If we've multiplied the bottom by 2, we also need to multiply the top by 2, and that makes it equivalent. Now 8/10 is an 8 in the tenths column, or 8 divided by 10, which moves the 8 one place value column over and gives us 0.8. So if it's out of 10, it's much easier. Or you can make it out of 100 if you find it easier. That would be 80 out of 100. And 80 divided by 100 is 0.8. So same answer that way as well. 8/10, 0.8. Question number 2. Write the following numbers in order of size. Start with the smallest number. So when we are comparing decimals, you might find it easiest to write them all on top of each other, lining up the decimal points. 0.4, 0.045, and 0.05, and then anywhere where you can see gaps or we want to make them all the same length, and you might just find that a little bit easier to compare. We're then just going to look at the tenths column. They've got all zeros in the ones column, so there's no point comparing those. Moving over to the tenths column, these bottom two numbers both have a 0, so these two are going to be the smaller numbers of the 4. So then we need to check the next column, and we've got a 4 or we've got a 5, and the 4 is smaller. So therefore that's going to be your first number. 0.045 is the smallest, and then 0.05 is our next smallest. Now we've done those two. Of the top two, we have a 4 in this column for both of them. So moving over to the next column, it's a 0 versus an 8. So it's going to be the one with the 0 that's smaller. So 0.4 is next, and then 0.48 comes after that. You can also kind of tell that it's 480, 400, 45 and 50, and you might just find that easier once you've made them all the same length, although mathematically that's not the best way of doing it, but if you do find those questions difficult, it's a good way of looking at it. Okay, question number 3, work out 20 add 6 divided by 2. Now this is going to be BIDMAS, so brackets, indices, division and multiplication are on a level and we just work from left to right, and addition and subtraction are also on the same level, and again we just work from left to right. Here I've got a division and an addition. So the division is more important. So we're going to do this bit first. So I'm going to end up with 20, add 3, because 6 divided by 2 is 3. 20 add 3 is 23, for 1 mark there. Question number 4, write 5.28 correct to 1 decimal place. 1 decimal place means you want one number after the decimal point. Now if we chop the number off and we check the next number, 8 rounds up, 5 and above rounds up, 4 and below rounds down. So because it's an 8, it's going to round that 2 up to being a 3. So 5.3 would be your answer there. Question number 5, write down the value of the 5 in the number 367.58. Now the 5 is in the tenths column. So you could say 5/10, like that. It has to be th, not 5/10s, because that's a different, that's that column, the tens column, the tenths column, or you can say 0.5. That is the value of it. You can't just write tenths, because it is, yes, it is the tenths column, but it's worth 5/10. So we want to see either of those two as our answer there. Question number 6. Here is a list of numbers: 6, 8, 15, 21, 24 and 29. From the list, write down a factor of 12. So factors are numbers that fit in an exact number of times. The factor of 12 here is going to be 6. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4. They're all numbers that fit into 12 an exact number of times. I chucked the 24 in there just to try and throw you off really, because 24 would be a multiple of 12. So 24 is in the 12 times table. So 24 is a multiple because it's bigger, it's in the 12 times table. 6 fits in an exact number of times, and that is a factor. Then we've got to do a prime number. Now your prime numbers are numbers that are only in the 1 times table and their own times table. They all have exactly 2 factors. So 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. Those are all the prime numbers up to 30. Obviously 30 is not a prime number because it's in the 10 times table, but those are all your prime numbers, and they are really, really worth knowing. They love to ask you on Edexcel about these two. I've seen them crop up quite a lot. So prime numbers between 20 and 30, 23 and 29, they're good ones to know. So here, which one have we got? Well, we've got 29. So 29 is the prime number there, and a cube number. Now, square numbers are when you times a number by itself, the answer you get. So 2 times 2 is 4, 3 times 3 is 9. These numbers here are square numbers. But we're going to go one step further here because we want a cube number. That means we do 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, and so on. So we're timesing the number by itself and then by itself again. So that's 1 or 8 or 27, and here we've got 8 in our list up here. So 8 is going to be the number that I put on the answer line there, and these are your cube numbers. So if you're asked about square numbers, it's going to be these ones here, and if you're asked about cube numbers, it's going to be these ones there, and it's good to know the first few just for the non-calculator paper. Okay, there we go. Question number 7. Jack and Harry are planning a trip to a festival. They will travel together by car. These are the costs for the trip. We've got total cost of petrol is £62. Weekend tickets for the festival are £120 for each person, and spending money is £60 for each person. Jack and Harry will each pay for themselves. They plan to save the cost of the festival over the next 4 months. How much do they each need to save each month? So each of them are going to pay half of the cost of the petrol. So £31 for each of them. I'm going to get 31 because I'm going to do 62 divided by 2. There are 2 of them. So 2 into 6 goes 3 times, 2 into 2 goes once. So therefore they each need to save £31 to cover the petrol. They each need to buy their own ticket, which is £120, and they each want £60 spending money. Adding that all together, I've got 1, 3 add 2 is 5, add the 6 is 11, so 1, carry the 1, and that is £211. So we then need to divide that by 4 because they want to save the cost of the festival over the next 4 months. So we're going to take 211 and we're going to divide it by 4. 4 into 2 doesn't go. So we're going to carry that 2 over. 4 into 21 goes 5 times, remainder 1. 4 into 11 goes twice, remainder 3. And I've got nowhere to carry that 3 onto, so I'm going to put 0 here and put 3 here. 4 into 30 goes 7 times, that's 28. And then I've got 2 left over. Again, I need something to carry that onto, so that is going to be 5 there. So they need to put aside £52.75 each over the next 4 months. If we multiply that by 4, you would get the total amount. So there we go, £52.75 is what they need to save each month in order to save for the festival and get the £211 each that they need. Okay, question number 8, expand. When we expand brackets, we're doing what's on the outside multiplied by the first thing and what's on the outside multiplied by the second thing. Each term in the bracket needs to be multiplied by what's on the outside. X times 2x is 2x squared, and x times minus 3 is minus 3x. They are not like terms, we don't put them together. That is our final answer for 1 mark. For part B, factorise fully, 14m squared minus 21m. Now we need to think what goes into both. Ultimately, these two questions are the opposite of each other. Expanding means taking out of the bracket. Factorise means putting back into the brackets. So what have these two terms both got in common? Because that's going to go outside the bracket. So 14 and 21 are both in the 7 times table, and both of those terms have an m in them. Then we need to think 7m multiplied by what would give us 14m squared. So we're going to need 2, because 7 times 2 is going to give us 14. And we're also going to need another m, because m times m would make us m squared. Then for the second term, I've got a minus, and I'm going to need to multiply it by 3. 7m multiplied by 3 would give me 21m. So that's going to be my answer there, 7m, 2m minus 3. If you wrote something like 7 lots of 2m squared minus 3m, so you forgot to take the m outside, that would get you just 1 mark there. So factorise fully is always a little bit of a clue that you can take more than one thing outside of the bracket. So there's more than one thing there. Part C, and we're solving 2 brackets y add 7 equals 11. So when we're solving equations, we want to make sure we're viewing that equal sign as the middle of the equation, and what we do to one side, we're going to do to the other. So first thing I'm going to do is expand the bracket. 2 lots of everything in the bracket, so 2y add 14 equals 11. Now I know that 2 lots of some number add on 14 equals 11. So we're now going to work backwards. I'm going to take 14 away from both sides. So 2y equals negative 3. Really important, if you're starting on 11 and you're taking away 14, you're going into the negative. So that's minus 3 there. So 2 lots of y is minus 3. And if we just want to know what y is, we'll need to just divide that value by 2. So y is negative 1.5. Minus 1.5 is your answer there for 2 marks. Question number 9. The pictogram shows information about the number of potatoes sold in a shop on Monday, on Tuesday and on Wednesday. And we've got some images there. And we can see over in the key that a whole circle represents 12 potatoes. So this is 12. Now every time you see half a circle, that's going to be half of 12. So we've got 6 there. This is 12. A quarter of a circle is a quarter of 12. And a quarter of 12 is the same as dividing by 4. So that's going to be 3. So we've got 3 there, and this one is 6. Okay, over the 4 days, the shop sold a total of 60 potatoes. Complete the pictogram for Thursday. So let's see what we've got so far. We can see on Monday, if we do 12 add 6, that is 18. On Tuesday, if we do 12 add 3, that's 15. And on Wednesday, there is just 6. So adding together those values that we've got so far, 18 add 15 add 6, is going to be 8 add 5 is 13, add the 6 is 19, so 9 carry the 1, and 1 add 1 is 3. So there have been 39 potatoes sold on Monday, Tuesday, Wednesday, so then let's do 60, take away 39 to see how many potatoes are left for Thursday. 0 take 9, if you've got more on the floor, borrow from next door. We're going to borrow 1 from there and make this 10. 10 take 9 is 1, and 5 take 3 is 2. So 21 potatoes on Thursday. Now a full circle is going to be 12. And if I did another full circle, that would be 24. So I don't want to do another full circle. From 12 up to 21 is 9 more. And we know that we can make 9 by using a half and a quarter. So therefore the shape I'm going to draw is going to be like this, 3 quarters, and that would be worth 9. 12 and 9 makes the 21 that we need, and that is now fully correct. So we've done part A for 2 marks. For part B, what percentage of potatoes were sold on Monday? Well, on Monday we had 18 potatoes sold out of 60 potatoes altogether. Now we want that as a percentage. Percentage is out of 100, and we've currently got this fraction out of 60, so that's no good. Let's try and simplify this fraction. I know I can simplify it because both of these values are in the 6 times table. So if I divide by 6, I'm going to get 3 out of 10, and that's a little bit easier to make that out of 100. I can make it out of 100 by multiplying the bottom by 10 and multiplying the top by 10. So because I've times this by 10, I'm also going to times the top by 10 to keep it equivalent, and that would be 30. So 30 out of 100 means that that is indeed 30% that is sold on Monday. Great. Okay, question number 10. There are 8 sandwiches in a fridge. The fillings of each sandwich are given below. Cheese, cheese, ham, cheese, turkey, tuna, ham and cheese. Write down the mode. So the mode is the most common. So we can see that cheese appears there the most. So cheese would be our mode. Just a reminder that median is in the middle, but you've got to put them all in order first. And the mean is when you add them all together and divide by how many there are. And then Harry is going to take a sandwich from the fridge at random. So on the probability scale, mark with a cross the probability he will take a ham sandwich. So how many are ham? 2 out of 8 possible sandwiches. So 2 out of 8 is equivalent to a quarter, and that's going to go here. 2 out of 8, if you count it in twos, 2, 4, 6, 8, so 2 out of 8 is going to go there. Then for part II, on the probability scale, mark with a cross the probability that he will take a prawn sandwich. Well, there are no prawn sandwiches in the fridge, so the probability of that is going to be 0. That's going to be impossible. Okay, question number 11. Reflect the shaded shape in the mirror line. When we reflect, we need to look how far away from the mirror line we are and make sure we go the same distance on the other side. So that vertice there is 1 square away. So we need to make sure we go 1 square away on the other side, and that's going to go there. Now this point here is 3 squares away from the mirror line, so it's also going to be 3 squares away on this side. This one's 2 squares away, and this one is 4 squares away, so that's going to go there. Joining them up with a straight line, I've got looking like this, and that would be where your shape needs to be for 2 marks there. Question number 12, write down the coordinates of the point A. So when we're writing coordinates, we need to make sure we go along the corridor up the stairs. So our X direction is first and then our Y direction. And we can see here that from the X direction, we're across at -4, and from the Y direction, we're up at 2. So my coordinate here is -4, 2. We're then asked to, on the grid, mark with a cross the point 3, -3. Label this point B. So the first number is how much you're going across, and the second number is how much you're going up or down, here down. So 3 -3 is going to be over here, and we're going to label that with a B. Then for part C, on the grid, draw the line with equation y equals -1. Now y equals -1 is the line that goes through -1 on the y-axis. So it's going that way, not vertical. It's really easy to confuse this with the y-axis itself. The y-axis goes the other way, so then it feels confusing that y equals goes horizontal, but it's the axis it's going through. So it's going through the y-axis at -1, and that is the line y equals -1. Question number 13. X degrees is 2/9 of a full term. Find the value of x. So we know that a full turn is 360 degrees. So what we're being asked here is 2/9 of 360 degrees. Now to do a fraction of a number, we divide by the bottom and then we multiply that by the top. So 360 divided by 9, we can use our bus stop method for that. 360 divided by 9. 9 into 3 does not go, we carry the 3 over. 9 into 36 goes 4 times, and 9 into 0 is 0. So that's 40. And then we want to do 40 multiplied by 2, because that's what's on the top of the fraction, and 40 times 2 is 80. So 80 degrees is our answer there. The value of x is 80. Question number 14. A stall sells large and small glasses of lemonade. A large glass is 300 ml and a small glass is 175 ml. Laura orders 5 large and 2 small glasses of lemonade. What is the total amount of lemonade that Laura has bought? So she's bought 5 large, so we're going to do 300 multiplied by 5. 5 times 0 is 0. 5 times 0 is 0, and 5 times 3 is 15, so that's 1,500. And she's bought 2 small glasses, so 175 multiplied by 2. 2 times 5 is 10, 2 times 7 is 14, add the 1 is 15, and 2 times 1 is 2, add that 1 is 3. So 350 there. Let's add those values together. 1,500, add 350, and that is 1,850 millilitres. However, we are asked in the question to give our answer in litres, and we know to get from millilitres to litres, we're going to be dividing by 1,000. So that is going to be 1.85 litres. For part B, write the ratio of the amount of lemonade in a large glass to the amount of lemonade in a small glass. Give your answer in its simplest form. So we're going to do large glass first, because that's the words of those are first in the question, and small glass second. Now we need to think, what times table are they both in? And they are both in the 5 times table. We can tell that because they both end in either a 0 or a 5. But I also can see that they're both in the 25 times table, because one of them ends in 0, 0 and the other one ends in 75. So we're going to divide both of them by 25. You can divide by 5 and divide by 5 again. That's absolutely fine. I'm just choosing to divide by 25 because it's a little bit quicker. So how many 25s go into 300? Well, we know that 4 25s makes 100. So that's going to be 12. And on the other side, 25, 50, 75, 100, and then 25, 50, 75. So that's going to be 7 on that side there. Just checking, 12 and 7 don't have any more common factors other than 1. So we're all good there. That would be my final answer, 12 to 7. Okay, question number 15. Tom is driving 200 miles to collect a new caravan. Tom leaves home at 6:45 a.m. It takes him an hour and a half to drive the first 80 miles. He completes the rest of the journey at an average speed of 40 miles an hour. At what time does he arrive to collect the caravan? So he's driving 200 miles in total. It takes him an hour and a half to drive the first 80 miles. Okay, so an hour and a half, 1.5 hours, and he's driven 80 miles. So he's still got 120 miles to go, because we know that in total he's going 200, and 200 take away 80 leaves me with 120, and he's doing this part of the journey at 40 miles per hour. Now, if we think about our speed, distance, time triangle, to get the time that it takes, we do distance divided by speed. So the distance is 120 divided by the speed, which is 40, and that is 3 hours. So we've got an hour and a half here and 3 hours here. So his total journey took 4.5 hours if we add those together. Now he left home at 6:45 a.m. So if I start at 6:45 and I add the 4 hours first, that's going to get me to 10:45 a.m. And then I've just got to go another half hour. So it would take me 15 minutes to get to 11 o'clock. And then I've got another 15 minutes to make that 30 minutes in total. So I'm going to get to 11:15 a.m. as my answer there for 4 marks. Okay, question number 16. Here are the first 5 terms of an arithmetic sequence: 2, 7, 12, 17, 22. Find an expression in terms of n for the nth term of this sequence. So for the nth term, we need to think, what are we going up in here, or what are we going down in? And because we're going from 2 to 7 to 12 to 17 to 22, I can see that we're going up in 5s. So this is a bit like the 5 times table, and we write that by saying 5n. 5n is the 5 times table, 5 lots of 1, 5 lots of 2, 5 lots of 3, and so on. However, it's not quite the 5 times table, because the 5 times table would start on a 5 and then go 10 and then go 15 and so on. So what do I need to do to adjust the 5 times table to get the sequence that we want? Well, instead of starting on a 5, I want 2. Instead of starting on a 10, I want 7. And that's 3 less in each term. So I'm going to do the 5 times table, take away 3. So my expression for the nth term is 5n take away 3. You might also find it helpful to think about what number goes here. If you went back by 5, you'd get -3, and that number is always correct to the constant term on the end there. And then for part B, we need to find the 15th term in the sequence. So the nth term gets us any number in the sequence All we have to do is change n to be the position number that we want. So in this case, we just need to change n to be 15, and that would tell us the 15th term in the sequence. So 5 times 15, and then we're going to take away 3. 5 times 15 is 75, take away 3 is 72. So that would be my answer there for 1 mark. Question number 17. 150 students were asked if they prefer pizza or pasta. The students were all in year 10 or year 11. 80 of the students were year 10. Right, so straight away we can put 150 at the beginning here and 80 in year 10. And then I can do 150 take away 80 to give 70 year 11 students. 30% of the students preferred pasta. Okay, so 30% of 150. 30% of 150. Now to get 10%, we divide by 10. So 10% would be 15, which means that 30% is equal to 45. So I need both of these to make 45. I don't know how many are in each at the minute though. 42 year 11 students said pizza, so this is 42. So I can work out the number of students saying pasta here by doing 70 take away 42. Now if there's more on the floor, borrow from next door. 10 take 2 is 8 and 6 take 4 is 2. So 28 is going here. And now I know that if I do 45 take away 28, I'll get the rest of the students who like pasta who would have been in year 10. So more on the floor, borrow from next door. 15 take 8 is 7 and 3 take 2 is 1. So 17 goes here. And then I've got 80 take away 17, which is going to give me the number of students in year 10 who said pizza, which is 63. There we go. And that all adds up to 150, so I would know I've done that correct. One of the year 10 students is chosen at random. Write down the probability that this student preferred pizza. So we're only picking from the year 10 students. If we were picking from everyone, this fraction would be out of 150, but I'm only picking from year 10s, so it's going to be out of 80. So out of 80, what's the probability they preferred pizza? Well, it's those 63 students that preferred pizza. So 63 out of 80 would be my answer there. Great. Okay, question number 18. So to do 4.08 times 3.7, there are two methods here, and I would like you to be using one or the other ideally. So 408 times 37, and I'm going to do this in the traditional way. So 7 times 8 is 56, 7 times 0 is 0, add the 5 is 5, and 7 times 4 is 28. So that's your top row. Now moving over to the 3, but it's actually 30, so we do need to put a 0 in there. 3 times 8 is 24, 3 times 0 is 0, add the 2, and 3 times 4 is 12. We're then going to add that together, and that is 6. 5 add 4 is 9. 8 add 2 is 10, so 0 carry the 1. 2 add 2 add 1 is 5, and then I've just got the 1 there. Now we would put the decimal point back in. So there's no point doing it with the decimal point in. That always leads to confusion with where it goes at the end. I would just multiply with the digits, and then we'll worry about that decimal point at the end. Now there's a few different ways you can work out where to put the decimal point. This is roughly 4 times 4. If you were going to round it, it would be 4 times 4. And we know that 4 times 4 is 16. So I know the answer is going to be fairly close to 16. So it makes most sense for me to put my decimal point here. What other ways could you do it? Well, you could say there are 1, 2, 3 values after the decimal point in the question. So there's going to be 1, 2, 3 going back from the end there afterwards. So 15.096. I'm happy that that makes sense, and that would be my answer. Method number 2 would be the lattice method. Now to do this, you're going to need to draw a grid that is 3 boxes wide because I've got 3 digits in that first number, and 2 boxes tall because I've got 2 digits in that second number. So I'm going to write that over the top, 4.08 multiplied by 3.7. Every single box needs to get split diagonally going down to the left. So diagonally like that. And I would split each box individually because it goes wrong less often. And then we just on the ends want to make them a little bit longer, so we've got somewhere to write our answer. Now all you need to do with this one is multiply the number at the top by the number at the side. So 8 times 3 is 24, so I'm going to put 24 there. 8 times 7 is 56. 0 times 3 is 0, so we put 0, 0. 0 times 7 is 0. 4 times 3 is 12. and 4 times 7 is 28. Now, it is worth saying, if you got a number less than 10, let's say you were doing 3 times 3, you would write that by putting 0, 9, for example, in the boxes. But we didn't have any numbers less than 10 there. And then all you do is add down each diagonal section like this. So in my first diagonal section, I've got a 6. 4 add 5 add 0 is 9. 2 add 8, that's 10, so 0, carry the 1 into the next diagonal section. 2 add 1 is 5, and then I've just got 1 in that section there. And that's my answer, 15.096, same thing. Now, what you need to do is go to the top where you've got a decimal point, and the side where you've got a decimal point. If you go across with one and down with the other, wherever they meet, you can go down that diagonal, and that tells you to put the decimal point there. So whichever way you prefer, but I would be really confident with one of those, and make sure you get your family members to quiz you, give you some decimal numbers to times together, and then check it on a calculator. Make sure you're super confident with that for 3 marks. Question number 2, work out 4 divided by 2 2/3. Give your answer as a mixed number in its simplest form. So when we are dividing fractions, most of you will know to keep, change, flip. But our first number here is an integer, it's a whole number. So I'm going to write 4 divided by. Now, the first thing we always need to do when we've got mixed numbers, whether we're adding, subtracting, multiplying or dividing, is make it top heavy. Now, 2 2/3 is 2 wholes and 2 out of 3, so 2/3 like that. So you've got 3/3 every time you have a whole. So we do the big number times the bottom number, because 2 wholes is 6/3, so 2 times 3 is 6. Add on that top number. So 2 times 3 is 6, add the 2 is 8. So 2 2/3 is 8/3. And then we're going to do 4 multiplied by 3/8. When we divide by a fraction, it's the same as multiplying by its reciprocal, which means inverting that fraction, turning it upside down. So keep, change, flip is how we often remember that. Now, this is a little bit tricky because we've got that integer, that whole number. So you might find it helpful to make it 4/1. 4/1 is the same as 4. So that's all good. And now we can just do what we would always do for multiplying fractions, and that is multiply the numerators together. So 4 times 3 is 12. And multiply the denominators together, so 1 times 8 is 8. Now, that is not a mixed number, and it's currently not in its simplest form. So how many 8s go into 12? Well, that fits in 1 whole time, with 4 left over out of 8. And then that fraction part there, 4/8, they're both in the 4 times table, so we can divide both the numerator and the denominator by 4, and that is 1½ as your final answer. Question number 3, write 72 as a product of its prime factors. Give your answer in index form. So for this, we want to start with 72 at the top and split it up into any 2 numbers that multiply together to give 72. You might do 36 and 2. You might do 8 times 9. I'm going to go 8 times 9 because why not? Then you need to think, are either of these numbers a prime number? Now I've got 2, 3, 5, 7, 9's not a prime number because it's in the 3 times table. You've got 11, 13, 15's not because it's in the 5 times table, 17 and so on, okay? These are all the numbers that have 2 factors, 1 and itself. They're only in the 1 times table or their own times table. If you get to a prime number, you're going to circle it, but if it's not prime, you're going to carry on. So 8 is 2 times 4, and 2 is prime, so we'll circle it. 4 is 2 times 2, so we'll circle those because they're prime. And 9 is 3 times 3, and they're both prime. Now, that is a correct tree, okay? And we could have done it a different way. You could have said 72 is 2 times 36, and then maybe 6 times 6, 2 times 3, and 2 times 3. Doesn't matter how you do it, you end up with the same answers, okay? We've got a 2, a 2, a 2, a 3, and a 3. So we're going to write that as 2 times 2 times 2 times 3 times 3. It is the product of its prime factors, and product means multiply. If you did 2 times 2 times 2 times 3 times 3, you would get 72. So we know we've done it correctly. However, it says give your answer in index form. So that means where we've got 2 times 2 times 2, we need to write that as 2 cubed times 3 squared. There we go. For part B, find the lowest common multiple of 72 and 90. Now we've already got 72 written as the product of its primes. So 2 times 2 times 2 times 3 times 3. That is how you make 72. I'm going to do the same for 90. So start with 90 at the top, and I'm going to do 9 times 10. 9 is 3 times 3. They're both prime. and 10 is 2 times 5, and they're both prime. And I'm then going to do a Venn diagram, and I'm going to have 72 on one side. Let's do it over here because I've got my 72 up here, and 90 on the other side. And what they've got in common can go in the middle. So 90 is 2 times 3 times 3 times 5. So both of these product of primes have 2's. So we can put the 2 in the middle. We can also put a 3 in the middle because they both have a 3. And they also have another 3. So we can put another 3 in the middle. However, there's nothing else left in common. The 72 has 2 and 2 left over, and the 90 has a 5 left over. If I asked you for the highest common factor, you would multiply together all of the numbers in the middle. So if I'd asked you for the highest common factor, which is the biggest number that fits into both, you would do 2 times 3 times 3. Now 2 times 3 is 6, times that by 3 is 18. So if I'd asked you the highest common factor, we would say that is 18. But I haven't. I've asked you for the lowest common multiple, which instead of being the biggest number that goes into both, is the first number in both their times tables. So you could have done this by writing out the 72 times table, 72, 144, and so on, and also writing out the 90 times table, 90, 180, 270, and so on. And the first number that you get to of both is going to be your lowest common multiple. But I find this way easier. So I've got my 18 by timesing together the numbers in the middle, and I'm going to times that by what's left on the outside. So I need to take that 18, times it by 2, times it by 2, and times it by 5, because those are the numbers that are left on the outside. Now, a bit of a sneaky trick here is that 2 times 5 is 10. So if you can save that till last, that's going to save you a bit of work, because 18 times 2 is 36, and we can then times that by 10 using up the 2 and the 5. So my answer here is 360. And if you'd have carried on going with both of these times tables, you would have got to 360 as the first number in both their times tables. Now, it doesn't matter what method you use there, but I tend to see this go wrong less often. When people write out the times tables, tend to miss 1 or miss 10 and go wrong that way and miss it. So there we go. That's 4 marks for that one. A really common question on the non-calculator paper. Question number 4. Billy, Nikki and Katie share some money. Billy and Nikki have £240 in the ratio 3 to 5. Okay, so when we're doing ratio, you guys will know I like to do my little lines here. 1, 2, 3, 1, 2, 3, 4, 5. So Billy has these 3 piles of money and Nikki has these 5 piles of money. So altogether they've got 8 little piles, and we know that we need to take £240 and share it over those 8 piles so that each of the piles has the same amount on it. So 240 divided by 8 is 30. So that means each of these little piles has £30 on it. 30, 30, 30, 30, there we go. Which means that Billy has £90 in total from those 3 piles, and Nikki has 5 piles of 30. So 5 times 30 is 150. 30 times 5. There we go. So then it says the amount of money that Nikki has to the amount of money that Katie has is in the ratio 3 to 2. Okay, so now these 3 piles are where Nikki's money are, and these 2 piles are for Katie. Now, we already know that Nikki has £150. So now if I had to share it over 3 piles instead, I'm going to take that 150 and share it equally over 3 piles, which is 50. So I've then got £50 here, £50 here, and £50 here. And with ratio, if those piles have 50 on them, then we know that these piles have 50 on them as well. So we're asked how much money does Katie have, and we can see that Katie has £100 because she has 50 and 50 on 2 piles. So £100 would be your answer there. Question number 5. There are only pink cubes, grey cubes and white cubes in a box. The table shows the probability of taking at random a pink cube from the box. The number of white cubes in the box is 3 times the number of grey cubes. Complete the table. So we know that with these tables, they always need to add up to 1. Probability adds up to 1, and so far we've got 0.4. So my first calculation here is to do 1 take away 0.4, which leaves me with 0.6. So I know that whatever I make these probabilities, they need to add together to make 0.6, okay? And then the whole thing will add up to make 1. Now it says that the number of white cubes in the box, this value here, is 3 times bigger than the number here. Now there's a couple of different ways you can do this. I could say that grey would be x and white would be 3x, because this number has to be 3 times bigger than that number. And together they make 0.6. So x add 3x equals 0.6, which means that 4x, because this is 1x, equals 0.6. If we divide that by 4, now 0.6 divided by 4. 4 doesn't go into 0, and 4 goes into 6 one time, remainder 2, but we've got nowhere to carry that 2 onto, so I need to put a 0 here. There's nothing in that column at the minute, so I can carry the 2 onto it. 4 into 20 goes 5 times. Therefore, x is 0.15, which means grey is 0.15, and white is 3 of those. 0.15 times by 3 is 0.45, or you can take it away from 0.6, doesn't matter. There we go. So we've completed the table. That would be correct. Another way of doing it, again, would be to use that ratio. So grey to white, you know it's in the ratio 1 to 3, and you know that all 4 of those have to be worth 0.6, so it's still going to be 0.6 divided by 4, and each of those piles has 0.15 on it, and that's how you get your answer that way. So you can use ratio or you can use algebra, it's completely up to you. 2 marks there. Question number 6, and we've got standard form. Write 0.00209 in standard form. So standard form is when you have a number between 1 and 10. It can't be 10, but it can be 1, times by 10 to the power of something. Okay, so because this is a really, really small number, it's going to be a negative power up here. We're going to be dividing by 10 rather than timesing by 10. And if you want to divide by 10, we still write times, but we make the power negative. So the digits I need between 1 and 10 would be 2.09. These are the digits I want, but I have to make it between 1 and 10, so 2.09. However, if I want it to be 2.09, let's zoom in here. If I want the 2 point to go there, then I would need to divide by 10, divide by 10, divide by 10. Now it's the values that are moving when I divide by 10. That 2 is moving column, the 9 is moving column, the 0 is moving column, but it's much easier for us to bounce that decimal point to show our working. So there we go. I've had to divide by 10, divide by 10, divide by 10 for that 2 to go from the ones column into the thousandths column where it is now. So that means because we've divided by 10 3 times, I'm going to write that as 2.09 times 10 to the power of minus 3. And that would be my answer for that one. For part B, 1.302 times 10 to the power of 4. Now 1.302, I'm going to times it by 10 4 times. That's a positive power, so we know we're just timesing by 10, we're not dividing by 10. So if I times it by 10 once, I'd get 13.02, so that's going to go there. Times by 10 again, times by 10 again, times by 10 again. And we'll put a 0 there to hold the place value. So this is going to be 13,020 as our answer. So 13,020 goes there, and 2.09 times 10 to the power of minus 3 goes there. 1 mark for each of those. Question number 7. ABCDE is a pentagon. EDF is a straight line. Angle CDE, so CDE, so that's the angle that's made there, is 30 degrees greater than angle BCD. BCD, that's the angle that's made there. Okay, work out the size of angle X. You must show all your working. So we know that this angle here is 30 degrees bigger than this angle here. So let's call this angle Y, and let's call this angle Y add 30. I don't want to use X because X is already at play over there. So Y and Y add 30. And we know that angles in a triangle add up to 180 degrees. Angles in a quadrilateral, a 4-sided shape, add up to 360. And every time you add a side, you add another 180 degrees. So a 5-sided shape, a pentagon, adds up to 540. And the formula for that is the number of sides, take away 2, times by 180. But if you forget that formula, it's kind of nice to be able to work up. So triangle's 180, and then every time you add a side, you add another 180 degrees, just in case you forget that formula in the exam. So here we go, we've got a 5-sided shape and we know that that adds up to 540. So far, what have we got? So I've got 120, 105 and 71. Let's add those together so far. 120, 105, 71. So 0 add 5 add 1, that's 6. 2 add 0 add 7, that's 9. And 1 add 1 is 2. So I've got 296 degrees so far. Let's now take the 540 that we know it needs to add up to and subtract 296. Now, if you've got more on the floor and you're subtracting, you're going to borrow from next door. That 4 becomes a 3 so that we can make this 10. 10 take 6 is 4. 3 take 9, again, you've got more on the floor. So let's borrow from next door. 13 take 9 is 4 and 4 take 2 is 2. Great, so we know that this one and this one, so y add 30 need to equal 244 degrees because that is what is left. We're then going to take 30 away from both sides. So 2y, because that's all I'm left with now, is 214. And then I'm going to divide that by 2. So y is 107 degrees. So that means that this one here is 107 degrees and this one over here is 30 degrees bigger, so that's 137 degrees. Now we're being asked to show what the size of angle X is, and angle X is on a straight line with this angle here. So I now know that those two angles will add together to make 180. So 180 take away 137, again, more on the floor, let's borrow from next door. 10 take 7 is 3, 7 take 3 is 4, and 1 take 1 is nothing. So your final answer there is 43 degrees for the size of that angle there, angle X. Question number 8. Complete the table of values for y equals x squared minus x minus 1. So this is the rule that we're going to use. To get the y value, we need to take x, square it, take it away, and then take away 1. Now you might find it helpful underneath here to do x squared, to do minus x, and to do minus 1 separately. And then we can add those three things together and get y, okay? So that might be helpful. First, let's think about x squared. Now we're going to start by doing minus 1. Minus 1 squared is minus 1 times by itself. So minus 1 times minus 1, and that is 1. We then want to take away minus 1. Now what happens when we take away minus 1? It becomes a plus. I'm actually going to change that to just plus 1. But then we also need to take away 1. This is just following this rule. So to get our value of y here, we need to do this bit, and this bit, and collect it all up. So 1 add 1, take away 1 is 1. Now we're going to do the same thing, but for 0. So 0 squared is 0. Minus 0 is minus 0, it's just 0. And then we're going to take away 1. So altogether, that is minus 1. Now we're going to do the same for 1. 1 squared is 1. Take away x, which is take away 1. Take away another 1. 1 take away 1 is 0. Take away another 1 is minus 1. For the next one, I've got 2 squared, which is 4. Take away that 2, and then take away the extra 1. 4 take away 2 is 2. Take away 1 is 1. A lot of ones at play here. And then for the last value here, when x is 3, I've got 3 squared, which is 9, minus that value, so minus 3, and then minus the 1. 9 take away 3 is 6, take away 1 is 5. There we go. So those are our values here. And then these are the coordinates that we're now going to plot on the graph. So minus 1, 1 is here. 0 minus 1 is here. 1 minus 1 is here, 2, 1 is here, and 3, 5 is here. I'm just plotting each of those coordinates that I selected in purple there. And then we're going to join that up with a nice smooth curve. So like this. Do my best on the iPad. Oh, there we go, like that. And that is us drawing that quadratic graph. Then it says, using your graph, find estimates for the solutions of the equation x squared minus x minus 1 equals 0. Now this is what you've just drawn. When does it equal 0? And it equals 0 in two places, here and here. So I'm going to give the two x values in those points. Now I'm going to say this one is minus 0.6. And I'm going to say this one is 1.6. Each of those little lines is worth 0.1. So my two answers there are minus 0.6 and 1.6. And you might be slightly different just from the way you've drawn your curve. So maybe they might accept anything from 1.5 to 1.7, and they might accept anything from minus 0.5 to minus 0.7 there as well. So a small range of answers just depending on the curve of your graph. And last but not least, question number 26. So for part A, make t the subject of h equals 3t minus 4. If we're changing the subject of the formula, it's a little bit like solving equations. We're just going to move stuff around until we've got that t on its own. At the minute, h is the subject of the formula because the h is on its own and everything else is on the other side. I want the t to be on its own. So I'm going to start by adding 4 to both sides, and that gives me h add 4 equals 3 lots of t. I don't want 3 lots of t though, I just want t. And to get that, I'm going to divide by 3. So dividing both sides by 3 gives me h add 4, all divided by 3. And so I'm going to swap that round for my answer, although you don't need to, but you do need to put t equals on the answer line. T equals h add 4, all divided by 3. For part B, y equals 3x squared minus 12. Work out the value of y when x is 5. So y is 3 lots of x squared. Now we would do the x squared bit first because we know from BIDMAS the indices come before multiplication, and then we're going to take away 12. So I know that x is 5, so let's pop that in there. 5 squared is 25. I'm then going to times that by 3. So 3 lots of 25 is 75, and then I'm going to take away 12. 75 take away 12 is 63. So that would be your answer there. For part C, simplify m to the power of 4 to the power of 3. Now a power of a power, we multiply them together. So that's going to be m to the power of 12. Don't confuse it with m to the power of 4 times m to the power of 3, which when we multiply, we add the powers. That's m to the power of 7, but that's not what we're doing here. A power of a power, you multiply them together to get m to the power of 12. I hope you found that predicted paper helpful. Please let me know in the comments if you've got any questions at all, and have a look at any of my other videos if you would like to do some more revision, and subscribe to my channel. Thanks so much, and I will see you guys soon.